Interpreting an audiogram. Audiologists describe, display and understand hearing loss using what's called an audiogram. It's essentially a visual representation of your hearing thresholds. Let's have a look at a few audiograms to get a better understanding of how to interpret them. Let's begin by looking at the axes of the audiogram here. First, let's look at the y-axis. As you can see here, this extends from -10 to 120. The measurement is in decibels hearing level, which is a scale describing the loudness of a sound, essentially. As you might imagine, smaller numbers mean softer sounds, larger numbers mean louder sounds. You can see that the scale extends to -10. It allows for negative numbers. How could you hear more than or better than 0 decibels? Well, it's a relative scale. We're measuring an amount of energy relative to another amount of energy. And so if you hear better than a normal average adult, you might have a hearing level which is in the negative side of that scale. In fact, it's common for most audiologists to stop testing at around 0 decibels, in fact, because relatively few people have hearing that better than 0 dB. And also, in many conditions, even in sound-treated rooms, it's hard to hear those softer sounds. Just to give some ideas, so sounds of about 20 or 30 decibels are very soft. There we're thinking about like a whisper type level. Sounds about 40 to 50 are conversational level speech, and then sounds about 60 to 70 might be like sort of moderate level music. Sounds about 90 to 100, there we're talking about things like construction work at a short distance, maybe a meter, and 120 like a jet plane engine taking off relatively nearby. What about the other axis? The axis across the top, the x-axis, extends usually on an audiogram from 125 to 8,000, shown here as 8K. It describes the pitch of the sound or frequency. So on the left-hand side at around 125, we have low pitch or bassy type sounds. At 8 kHz, we have a high pitch or squeaky type sound, and it's arranged a bit like a piano keyboard, although the scale is somewhat different, obviously. So from low to high pitch across from left to right there. Just to give you an idea of the kinds of sounds you're thinking about there, for a high-pitched sound, you can imagine the sharpness in a syllable like s, s, an S sound. And for a low-pitched sound, you might think of a vowel sound having peaks in energy around 250 to 500 hertz. Ooh, ooh, ah, ah. Those are relatively low-pitched sounds. So that describes the two axes of the audiogram. Now we put those together, of course, and we can talk about how loud a sound is that someone can hear, and at what pitch do they hear that well or that poorly. Let's have a look at some example audiograms to better understand that concept. Here we've got an example of a normal hearing adult. So we can look at the different frequencies, 250, 500, 1 kHz, 2 kHz, 4 kHz and 8 kHz here shown. And we can look at the level shown here. All of those results are less than 20 to 25 decibels. And we can say that for all of the different pitches, that person is hearing within normal limits. You'll notice that there are circles, shown here in red, and crosses, shown here in blue. Those results are the results of the right ear and left ear respectively, red for right, blue for left. So we're showing the responses from each ear on the audiogram. In some cases, these results will be collected via a headphone, like an earmuff, basically, and in some cases, these results will be collected via what we call insert phones. A little foam plug is inserted in the ear. In both cases, sound in the normal fashion is presented through those devices and enters the ear canal. And if you look at the further description on the page, you'll see what happens is that the sound is a movement of air particles which moves the eardrum or tympanic membrane, vibrates the ossicles or ear bones, vibrates fluid within the cochlea, which is attached to that final ear bone, and that vibration of the fluid in the cochlea or inner ear will vibrate tiny little hair-like protrusions in the inner ear, which will allow an electrical current to travel through the membrane, creating action potentials, creating little electrical excitations which travel up the hearing nerve and which are interpreted at the level of the brain as sounds. So in this case, this person has been responding at all those different frequencies or pitches in the normal range. They have normal hearing in both the right and the left ear. If the results were further down, between 25 to 40 dB, we would say the patient has a mild hearing impairment. Between 40 to 60, a moderate hearing impairment. Between 60 to 80, a severe hearing impairment. And below 80, a profound hearing impairment. Let's look at some examples of different audiograms. Here we see a patient with a difference between their ears. This would be an asymmetrical hearing loss. In fact, you can see that in the right ear, shown here in red, the hearing thresholds are in the normal limits, up the top of the graph for all of the frequencies. However, for the left ear, shown here in blue, you can see that the levels end up towards the profound range, although they begin in the normal range for the low frequencies. At 250 Hz, the left ear shows a threshold of 10 decibels within the normal range. Yet by the time we get to 1 kHz or 1000 Hz, the threshold is 80 dB and has moved into the profound range. This hearing loss might be described as a profound hearing loss, or some would describe it as a normal to profound hearing loss. Sloping, perhaps, they might add as well, to give you an idea of the shape of that hearing loss across the frequency range or across the pitch range. Here is an audiogram showing a bilateral hearing loss. The hearing loss is mild in the low frequencies and progresses to moderate in the mid to high frequencies. This patient has a bilateral, meaning both ears, bilateral, mild to moderate hearing impairment. We can introduce another concept here, which is the idea of showing not just the level of hearing loss across the frequency range on the audiogram, but also providing some indication of where in the system the pathology is occurring. It's a relatively gross amount of information we can provide about where in the system the pathology is occurring on the audiogram. We indicate essentially whether the pathology is in the cochlea or higher in the system, that is in the hearing nerve at some point, or whether the pathology is in the middle or outer ear. And we do that by showing a measure called bone conduction. You can see the bone conduction results here, shown in blue. They look like a greater than symbol. And we can see at 500 Hz, 1 kHz, 2 kHz and 4 kHz, although they overlap a lot with the circles and crosses, that there are individual measurements of the patient's bone conduction. So what does bone conduction mean? Well, as stated before, the circles and crosses are measurements made with a headphone or insert phone inserted into the ear, creating sound in the normal fashion. A bone conductor is a solid device placed on the back of a patient's ear, just behind the ear actually, on the mastoid bone usually, but it can also be placed on the forehead. This device will vibrate. That vibration, that physical vibration of the bone, will send a vibration through the cochlea, well, through the fluids in the head. By vibration of the bone directly, it will distend the cochlea itself. Basically, the energy will arrive inside the inner ear, and it doesn't have to go through the outer or middle ear system. So we can almost imagine it as a direct measure of the cochlear function or inner ear function. So, in this case, we can see that that measure of inner ear function is the same, essentially, as the measure we got from the earphone or headphone. In cases like these, the loss is, we can say that the loss is within the inner ear. We call it a sensory neural hearing loss. Losses which occur in the outer or middle ear, we call conductive hearing losses. And we'll see an example of how that will be shown on the audiogram if that were the case. But you may be already able to imagine that in cases like that, actually when we test via the bone conductor, the results are much better. That is, the inner ear is fine, is not damaged, and so when we send a vibration through to those parts of the ear, the results actually look quite good. When we test through the headphone or earphone, the results look poorer. And that difference between the bone conducted measure and the inner ear measure, or the complete system measure I should say, indicate to us that the patient has a conductive pathology, a pathology in the outer or middle ear somewhere. Let's look at an example. Here we see a patient with a right ear which has a mild hearing loss. Close to the normal range, in fact. Those red circles just dip out in the low frequencies. You can see that the red, in this case smaller than symbols, which indicate the bone conductor being placed on the right side of the head, show results in the normal range, in fact. If we look at the left-hand side symbols, shown here almost like a staple in the normal range as well, at the top of the graph. Those are the bone conduction results for the left ear. The left ear conduction results, the results obtained under headphones or through an insert phone, however, are much lower. They're down towards the severe range. So there is a significant difference between the results obtained under headphone and under bone conduction for the left ear. That gap, that difference between those two measures indicates that there's a pathology in the outer or middle ear. There are some very specific situations where this measure is not a good indication of the site of pathology. But in general, this would indicate that the patient has a problem in their outer or middle ear. We wouldn't be surprised, for instance, to see a patient with results like this who has perhaps absent ear bones ossicles, or who's had severe pathology in that middle ear region. We call this kind of loss, as stated before, a conductive hearing loss. There's a problem conducting the sound into the inner ear. In this case, the patient has a severe conductive hearing loss on the left side and near normal, but perhaps we would describe it as a mild hearing loss in the right ear. This audiogram shows a mixed hearing loss. A mixed hearing loss has elements of sensory neural and conductive in the same ear. In this case, both the left and the right ear show a mixed hearing loss. That is, both ears have an element of conductive pathology, perhaps of the outer or middle ear, and an element of damage to the cochlea or hearing nerve, or a sensory neural hearing loss. It's mixed because it has elements of both. How do we know that this shows a mixed hearing loss? Simple. Both the bone conduction in the left and the right ear are not normal. They're reduced. If we look at the right ear, the right less than symbols shown here show a sloping hearing loss. They're not in the normal range. The left staple marks, which show the left ear's bone conduction, show they're outside the normal range as well. They show a mild to moderate hearing loss. Neither of the bone conductions are in the normal range. So there is a sensory neural component to the hearing loss in both ears. However, if we look at the air-conducted sound, the sound conducted through headphones, we can see that the right ear, shown here in red circles, is below the right bone conduction. There is a gap between the bone conduction and the air conduction, or the bone conduction and the headphone-produced sound, suggesting that there is a conductive component in the right ear as well. In the left ear, we can again see that there is a large gap between the left blue bone conduction results, shown by the blue staple marks, or bracket, and the left air conduction thresholds, which are shown here with blue X's. So again, the left ear has a conductive component to the hearing loss as well. Once again, both ears have both a sensorineural component, shown by their reduced bone conduction, and a conductive component, shown by the gap between the bone conduction and the air conducted results, suggesting that both an outer or middle ear and a sensory component to the hearing loss is present, a mixed hearing loss. In terms of the level of the hearing loss, we can see that the right ear shows a moderate hearing impairment, dipping down to a severe hearing impairment in the high frequencies. And in the left ear, the hearing loss begins in the severe hearing impaired range, moving to the profound hearing impaired range in the high frequencies. To describe the audiogram, we would say that the right ear shows a moderate to severe mixed hearing loss, and the left ear shows a severe to profound mixed hearing loss.